Nichrome generally refers to any alloy of nickel, chromium, and often iron or other elements or substances. Nichrome alloys are typically used in resistance wire. They are also used in some dental restorations and in other applications. History. Patented in 1905, it is the oldest documented form of resistance heating alloy. A common alloy is 80% nickel and 20% chromium by mass, but there are many others to accommodate various applications. It is silvery gray in color, is corrosion resistant, and has a high melting point of about 1400 degrees Celsius. Due to its resistance to oxidation and stability at high temperatures, it is widely used in electric heating elements, such as in appliances and tools. Typically, nichrome is wound in coils to a certain electrical resistance, and current is passed through it to produce heat. Uses. Nichrome is used in a very wide variety of devices where electric heating is required. Almost any conductive wire can be used for heating, but most metals will be rapidly oxidized when heated in air. When heated to red-hot temperatures, nichrome wire develops an outer layer of chromium oxide, thermodynamically stable in air, mostly impervious to oxygen, and protects the heating element from further oxidation. Nichrome is used in the explosives and fireworks industry as a bridge wire in electric ignition systems, such as electric matches and model rocket igniters. Industrial and hobby hot wire foam cutters use nichrome wire. Nichrome wire is commonly used in ceramic as an internal support structure to help some elements of clay sculptures hold their shape while they are still soft. Nichrome wire is used for its ability to withstand the high temperatures that occur when clay work is fired in a kiln. Nichrome wire can be used as an alternative to platinum wire for flame testing by coloring the non-luminous part of a flame to detect cations such as sodium, potassium, copper, calcium, etc. Other areas of usage include motorcycle mufflers in certain areas in the microbiological lab apparatus, as the heating element of plastic extruders by the RepRap 3D printing community, in the solar panel deployment mechanism of spacecraft light sail, as the heating coils of electronic cigarettes. The alloy price is controlled by the relatively more expensive nickel content. Distributor pricing is typically indexed to market prices for nickel. Properties. The properties of nichrome vary depending on its alloy. Figures given are representative of typical material and are accurate to express significant figures. Any variations are due to different percentages of nickel or chromium. Table 1. Resistance per inch. Closed helix. 80/20 alloy. Table 2. Current versus temperature characteristics. Straight wire, showing approximate current necessary to produce a given temperature, applying only to straight wires stretched horizontally in free air. Values for diameters from 0.040 through 0.010 are based on coiling on an arbor 0.12 diameter and stretched to twice the close wound lengths. Table 3. Cold resistance and wire gauge versus power output at operating voltage. In the following table, the alloy named nichrome V is specified as 19 to 21% Ni, 2.5% Mn, 1.0% Fe, 0.75–1.6% C, 0.15% C, balance, Cr. Additional properties. NiCr chemical composition. 80% Ni, 20% Cr approx. Melting point. 1400 degrees Celsius NiCr chemical composition. 61% Ni, 15% Cr, Bal. Fe approx. Melting point.